Hello. All right. Welcome to another fun-filled video with Mr. Sims. I welcome you today to the test incentive video for Cycle 2. I hope you're having a wonderful night. I commend you on actually studying for this now. What we're going to do for this is we're going to start off by telling you to write your name in the upper right-hand corner of your paper. Remember, I want your full first name and your full last name. Underneath that, I want you to write math is my life. Once again, math is my life. And then you can write your period number and your date under that, because both of those are really good things to bring into this as well. All right, so in the upper right hand corner, once again, your first name and your last name. Right under that, I want you to write math is my life. Then under that, you put the period number and the date. And I just want you to know I'm glad you're here. Thank you for watching, most of all because it helps you, and that's exciting, but also because I just like to see you do amazing stuff. So let's go ahead and get to this before we go any further. I'm going to basically just try and get through as much as I can possibly get through in about 30 minutes. So I'm going to set the timer here on Alexa, and Alexa's going to tell me when my 30 minutes is through, and basically wherever that's at, I'm going to basically stop right about there. All right, so bear with me. You're getting about 30 minutes of study time with Mr. Sims. All right, here we go. Alexa, set a timer for 30 minutes. Thank you, Alexa. All right. Pardon me. All right, so first one here, we're going to solve for x. So in this problem, we solve for x. The way we do that is we add 7 to both sides, right? The reason we do that is because this is the term, that's the variable term. This is the constant on the same side, and we want to isolate this variable term. We want to get it alone. So I add 7 to get rid of that constant on the same side. So now I have 2x on this side is equal to negative 31 plus 7. Negative 31 plus 7 is going to be 24. All right, so I think that's right. Negative 24. Thank you. Negative 24 divided by 2, because now I have this operation present with the 2. I have, with the x, I have it multiplied times 2. So in order to get rid of by that, I have to divide by 2, right? Then I go over here, I have to do it to the other side. What I do to one side, I must do to the other side. So now I get x is equal to negative 12. And that is my final answer. Perfect. All right, so that's your first problem down. Perfect. Now, let's move on to the next one. A function is described by the equation y is equal to 5x plus 6 if the value of y is no more than 26, which inequality best describes the domain of the function. Now, that is a scary looking problem if you have no idea what to do. So let's go ahead and dissect this and see if we can just kind of remove some of the mystique around it. A function is described by the equation y is equal to 5x plus 6. So this is my equation here, y is equal to 5x plus 6. That's going to come in handy in a second here. If the value of y is no more than 26, so the value of y is no more than 26, which inequality best describes the domain of the function? So what they want is the domain. In other words, they want all of my possible x values for this. Well, this one here is saying y is no more than 26. Well, isn't that my range? Because your range is your y values, right? So when it tells me y is no more than 26, it's saying that's the range you're working with. Well, now I have the range, I want my domain, and I have an equation here. So these are the pieces that I have at my disposal. I'm going to start by turning my range into mathematical language that I can understand. So it says y is no more than 26. So if I was writing that as an inequality, I would say I'd put y here and 26 here, and I would say that my y it can't be more than 26, so I know it has to be at least less than 26. But it also could be equal to, because it's no more than 26. So it could be equal to it. So this right here is my range. Y is less than or equal to 26. Well, that is my range, but I don't want my range, I want my domain. So all I have here is my range, and the only other pieces that I have here to work with is the actual equation itself. So what I'm going to do is I'm going to look at this equation, and you'll notice that the equation equates y with this over here. In other words, it's saying that this is the same as this here. In other words, 5x plus 6 is the same as y. So wherever I see y, I can actually plug in 5x plus 6. And that's what I'm going to do. I'm just going to plug in 5x plus 6 for y. In other words, I took this here and I'm putting it in for here. right? That's 5x plus 6 going into y. So then I just bring down my less than or equal to sign and I bring down my 26. Well, now what I have is I have an inequality that I can solve to figure out what my domain is. It'll tell me all my possible x values now. So what I'm going to do is I'm going to, once again, I have a variable term and I have a constant on the same side. I'm going to subtract by 6 on both sides in order to isolate this variable, right? These two cancel out and I get 5x is less than or equal to 20. Now, I'm going to go ahead and since x is being multiplied by 5, I'm going to divide by 5 to get x alone. And I get x is less than or equal to 4. And that right there should be my answer. Now you'll notice there's this answer here and there's this answer here that are close to this. These are both off, right? But these two are close. This is why it was very important that at the beginning we included this equal sign, because remember y is no more than 26. So this means that x can actually equal that 4 as well. So it's important that the answer is D and not A. It's not a mistake they put A first. They're hoping to kind of trick you into choosing one quickly. All right, let's go ahead and move on to 8 now. 8 is one where we're simplifying exponents. If you struggle with simplifying exponents in any form or fashion, my suggestion for you is to watch my exponent videos. I actually have 2 exponent videos, and the place I have those are on Math for Gremlins, which is our YouTube channel to help with Algebra 1 concepts. So once again, Math for Gremlins, this is actually probably where you're watching this particular video anyway. So exponent videos, there's 2 of them on Math for Gremlins. Go watch those if you're struggling with this at all. It will give you a really good foundation, okay? But anyway, let's go ahead and without dilly-dallying, I'm going to start by doing the rule that we're going to need. This is called the product of powers rule, right? So the product of powers rule states that if I have a to the m and I multiply it, right, by a to a different exponent, or even the same one, right, that if I have a base to an exponent multiplied by that same base to a different exponent, that the answer, if I wanted to simplify those, if I wanted to multiply them together, I would end up getting a to the m plus n. In other words, we would add those 2 exponents together. Now this only works for like bases. I can't join this x and y together because those are actually completely different bases. So I'm going to take the x first. I'm going to start with x because this x is being multiplied by this y, but it's also being multiplied by this x over here, right? So what I'm going to do is I'm going to write my x, and I have a x to the 6, x to the 4th. So x to the 6 is my first exponent, like here. X to the 4th is my second one. So I can add those 2 together to get x to the 10th. All right? And then I have y squared and y to the 5th. So that's going to become y to the 7th. Okay, that's how I draw my 7s in case you're wondering. And that is the final answer. Piece of cake, right? Yeah. So once again, if you're struggling at all with that or you want more practice on that, watch that video, those videos, exponents for Math for Gremlins. Okay. Here we go. Moving on to number 11. Solve for D. Express your answer in simplest radical form, if appropriate. So this one is basically a simple solve for D. We have a D squared though. So the operation present is squaring, and I want to solve for D alone. So I have to do the opposite, which is taking the square root. Well, if I do it to that side, I must do it to the other side as well. So I get D is equal to, and at this point, you got to remember that whenever you take the square root of D squared, whenever you're solving for that variable by taking the square root, you have to incorporate the plus or minus. Otherwise, you're only going to get the half question basically half right, right? Because there's a positive and a negative root. So at this point, I'm already going to introduce that plus or minus to make sure I don't forget it. So I get D is equal to plus or minus the square root of 24. So now I just have to simplify that 24. And the way I'm going to do that, the square root of 24 rather, the way I'm going to do that is that I'm going to start by making my perfect squares chart. So here we go. I'm just making a list. Oh, that's a horrible, horrible, horrible line. Let me fix that. All right. There we go. And I'm just going to start by saying 1 squared is 1. 2 squared is 4. And I'm not going to do draw all the squares because I just want to make sure that I don't waste a lot of time. So 3 squared is 9. 4 squared is going to be 16. 5 squared is going to be 25. At this point, 25. At this point, I'm already over that 24, so I can stop there. My 24 basically fits right in here in this section here, right? So I'm going to start dividing that 24 by each of these numbers here, okay? So I'm going to start by dividing 24 by 16. Well, 24 by 16 gives me a decimal number, so that doesn't work. 24 by 9. 24 by 9 also gives me a decimal number if I divide it. So I'm going to divide 24 by 4. Hey, when I divide 24 by 4, I do not get a decimal answer. I get a whole number. So that tells me that the perfect square that goes into it is going to be the square root of 4. In other words, my first factor is this 4 that went in evenly. Now, when I divided 24 by 4, it gave me another number. That number that it gave me was 6. In other words, 4 times 6 is 24. Notice that I put the one from the chart first. I highly suggest you do that so you don't make this mistake, because now it's a really simple process. You know that you have to simplify the first factor that you got, the one that was from the chart. Square root of 4 simplifies easily into 2. And you can tell that because we got 4 by taking 2 squared, right? So if I want the square root of 4, it's just going to be 2, right? And just do that in your calculator if you're struggling. The square root of 4 is 2. And then the square root of 6 does not simplify any further, so it just stays like that. So my answer is D is equal to the plus or minus 2 square roots of 6. All right? Sounding good? If you're struggling with that, I highly suggest you watch the video on that. There's a video. It's on the Cycle 1 helpful videos. If you look on Google Classroom, it's on there. I haven't made one yet for Math for Gremlins, but I do want to make one soon that will maybe give you more practice on that. But for now, that's a great video that I made a while back. It's just not as perfect as I want it to be. Moving on. Here we go. Number 16, solve for n. So this problem is actually not too bad. What you're going to do is you're going to look at these and first of all recognize that, hey, these are two like terms, right? I can combine this 6n and the 3n, the 6n and the 3n to make 9n with their forces combined, 9n. Now I also have this plus 8 that I'm going to bring down, right? And all of that's equal to what? To 80, okay? So I have this now. Now, I want you to recognize we can't combine these terms, right? They're different terms. This is a variable term and this is just a constant. So I can't combine them, but what I can do is I can solve for this n now because that's what they want me to do. So I'm going to deal with the constants on the same side as the variable term. And I'm going to subtract 8 to get rid of that, right? I want them to cancel out, right? When I do that, I get 9n. I'm just going to bring my 9n over. I'm just pulling it over here. Is equal to... This is going to be 72. So I have 9n is equal to 72. So now I'm going to divide by 9 because 9 is multiplied times the n. So I got to do the opposite operation of that. I'm going to divide by 9 here, right? And I get n is equal to 8 because 9 times 8 is 72. Therefore, 72 divided by 9 is 8. And that is my final answer. Yay! All right. Hopefully you're doing a great job already. Here's what I want you to do. In the bottom right-hand corner of your paper, right at the very bottom right-hand corner, I want you to draw a caterpillar. In the very bottom right-hand corner of the paper, draw a... No, actually, yeah, draw a caterpillar. Yeah, let's do that. Draw a caterpillar in the very bottom right-hand corner. All right, moving on. Here we go. Let's do another problem. So we have solve for x. 20 says solve for x. So it says 2x minus 6 over 4 is equal to 20. So what I'm going to do here, I'm going to start off by realizing that all of this is divided by 4. So the first thing I got to do is try and get that out of the denominator. And the way I'm going to do that is by multiplying it by 4, because then I can deal with all this stuff on top. So I multiply both sides by 4, and these 4's will now cancel out. Because remember, 4 over 4, right? If you have a fraction, 4 over 4, that's equal to 1 whole, right? So that's why that cancels out in case you were wondering. But anyway, moving on. 4 over 4. So now I'm left with 2x minus 6 is equal to 20 times 4, which ends up being 80. So now to solve for x, I have a regular stupid two-step equation now, right? So I start off by adding 6 because this is the constant that's on the same side as my variable term, right? I want to get rid of it, so I do the inverse operation of subtraction, which is addition. These two will cancel out, and I get 2x is equal to 86. Now I have to divide by 2 and divide by 2. I'm going to move this up just a hair. And when I do that, these cancel out again, and I get x is equal to 43. And that's my final answer. All right? Hopefully that made sense to you. Hopefully you're doing that pretty well by now. Once again, regular two-step equations, okay? Here we go. Let's go ahead and move on to the next one in the interest of time. All right, let me zoom out of that so you can see a little bit more. Here we go. Mr. Juarez. Oh, here we go. Mr. Juarez earns, we'll get to that one later. Mr. Juarez earns $10 per hour at his job. This week, he will work no more than 40 hours. His total weekly earnings are a function of the number of hours he worked. Which best describes the range of this function? So this is one of those problems. It's a word problem, and immediately a lot of kids are already freaking out because it's a word problem, right? But I want you to notice it's actually not that scary if you think about it carefully. He earns $10 per hour. So we got a $10 per hour at his job, right? This week he will work no more than 40 hours. He will work no more than 40 hours. His total weekly earnings are a function of the number of hours he works. So in other words, if the weekly earnings are a function of hours, that's saying that hours are the independent variable. Hours are things that he can just change willy-nilly. He could choose how many hours he's going to work, and the weekly earnings will adjust accordingly, right? So the hours are the independent variable, or the x value. In other words, the domain is hours. So once again, his domain is hours. So then that only leaves one other thing to be the range. That leaves his earnings, his weekly earnings, to be the range, right? That's the range, the y values. So what I need to do, first of all, is it says he will work no more than 40 hours. So that's actually giving me the domain. I need to convert that into mathematical language. So if he's working no more than 40 hours, then I have to say my x values, my possible x values are going to be x are less than 40, right? He's working no more than 40 hours. But notice he could work actually 40 hours as well. So I need the equal to sign. So this is my domain here for this problem. X is less than or equal to 40 hours. But they don't want the domain. What they want is the range. And luckily, they were really nice to you. They got all the y values here, so you know you're looking for the y values, right? So what I need to do in order to solve this here, right? If he's working no more than 40 hours, x has to be less than or equal to 40, but he's not going to work negative hours either, is he? He's not going to work like negative 1 hour. That's not even possible. So I got to make sure that my x, that 0 stays less than or equal to x. In other words, he could work, this is my domain, he could work from 0 to 40 hours a week. These are all the possible hours that he could work. All of those, right? He could work 1.5 hours, 2.398 hours. He could work all of those all the way between 0 and 40, okay? So it's a continuous function between those two. So that's the domain. I'm going to write that here so we don't get confused, okay? And I need to find the range. So because I need to find the range, what I'm going to do now that I have my domain is I'm going to look at what my range would be. Well, in order to find the range, what I need to do is actually incorporate this $10 per hour to find his weekly earnings. Let's ask the question. If he were to work 0 hours, right, how much money would he make? Well, he ain't going to make anything if he's working 0 hours, right? Because we have to multiply it by that $10 per hour, right? So we multiply it times 10, but 0 times 10 is still 0, right? Well, let's look at the higher end then. That's the least amount of money he can make. What's the most amount of money that he can make? The most amount of money he could make then would be if he took that 40 and he also once again multiplied it times 10, and he would get 400. All right? So that's a horrible, horrible brace. Let me try that again. There you go. So that's 400. So the least he could make is 0. The most he could make is 400. I need to put my y value in between and add my less than, right? Because these are less than or equal to, I need to make sure my y values are also less than or equal to. So this right here is my range for this problem. And you'll notice that there's some other answers that are crazy answers, but this is the right answer right here, this F, okay? Y is less than 400 doesn't work because that would mean that he could actually get negative money, and he can't get negative money, right? That doesn't even make sense. So, and it also doesn't include the 400, which it would need to include the 400 because he could actually make the 400, right? So the correct answer is F there. All right, hopefully that one made sense to you. If not, maybe go watch it again and see how to do that one more time. You'll definitely need to be confident in that so you're not messing it up during the test. All right, let's go ahead and move on to this problem here, which is number 10. All right, moving on to number 10. All right, number 10. So number 10 says, the graph below shows the relationship between the account balance and the number of months' money has been withdrawn from the account. Which best represents the domain of the graph? That was supposed to be underlined, but that was a horrible job. Domain of the graph. Remember, your domain is your x values. Whenever you see domain, I want you to think x values. So in this case here, his domain, they want to know basically what is the domain of this entire graph. Well, you'll notice, first of all, is this data discrete or is it continuous? Remember, discrete is singular points, right? Like this would be discrete data here if it was singular points. But it's not singular points. It is a line, which means I can have any x value between here, which is where this line starts, right? And here. In other words, I can have 0, 1, 2, 3, and 4, but I can also have 0.5, right? I can also have 0.25. Heck, I could also have 0.187539. If I look for when x is 0.187539, I'm going to get some answer like 397 maybe. Does that make sense? So this data, there's definitely x values all the way up and down here. There's x values here. Really, there's an infinite number of points on this line that I can choose from, right? So because there's an infinite number of points, I need continuous. I'm going to need a continuous domain for this, right? So in other words, my domain is not just going to be a list. My domain is going to be something like x such that, and then my x value is going to be here, right? I have my less than on both sides of my x, right? Ugh, that's so ugly, all right? And my question is, and then I need a lower bound and I need an upper bound, right? I always tell you guys, start with that, right? Figure out your upper bound, lower bound, then decide if you can be equal to it, okay? So let's go ahead and look at what's my lowest bound. What's the lowest x value I can have according to this graph? Well, it looks like it's right here at this 0. I'm going to erase those because that's really annoying me. Let's go ahead and erase that real quick. And that. So my lowest x value according to this looks like it's right here on my 0 line, right? So 0 is actually going to be in my lower bound. I'm going to put it there. And my upper bound looks like it's going to be right here at this 4, okay? So what I can do is I can write 4 here. And notice I can actually see this point at 4, and I can see this point at 0. So I have to actually include these, right, at that point. So my answer then, my domain is going to be 0 is less than or equal to x is less than or equal to 4. And I like to show you that this is notation x such that 0 is less than or equal to x is less than or equal to 4. So which one resembles that the most? This is the part you're looking for particularly, right? You have 0 is less than or equal to x less than or equal to 4. This one looks like it's right? This one looks like it's got 400, which would actually be part of the range here. So that one's out. This one's way out. Between 4 and 400. That's just kind of weird. That's taking an x value and a y value. That doesn't even make sense. And then this one here would actually be range. This is range, but they don't want range. They want domain. Notice it's a y value too. So there's no reason you should choose D. That's the range. So So anyway, it looks like our answer is A. Da, 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 da. All right, moving on. Next problem. Simplify. Answer using only positive exponents. So once again, this is an exponent problem. There will be a lot of these. There's going to be a lot of these throughout the year. So what you need to do is get accustomed to them. I suggest watching those exponent videos once again and doing them. Don't just watch the video. You actually have to do them to learn anything. But anyway, this one here, to solve this problem, you're going to use the product. No. The power to a power rule. Sorry, my brain just froze on me. You're going to use a power to a power rule. So here's my a to the m, which is my first power. It's raised to the n power. So I have a base with a power raised to another power. And the answer that I get when I do that, if I want to know how to simplify that, it would be a to the m times n. In other words, I'm going to multiply those two together. So in this case, in this scenario, I have x to the fifth squared. So in order to simplify that to just one single x, I get x, pardon me, x to the fifth squared is going to be x to the 5 times 2, which is 10. Now, if you want to actually see that worked out, we can actually expand this. Let's expand it real quick. X to the fifth is going to be x times x times x times x times x, right? That's x to the fifth. But notice I need 2 copies of that multiplied together. So here's the other. There's the other copy of it, right? That's 2 copies of x to the fifth all multiplied together. And how many x's is that all multiplied together? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So the answer is x to the 10. If you need to do it that way to get it right, then by all means do it that way. You need to move on to actually memorizing the rules, but that's a short stopgap measure. I'd rather you get it right on the tests as you're learning it, but definitely get the help you need, right? Learn those rules by memorizing them. All right, this problem is a lot like the other problem that we did on the other page, except you'll notice the other one was a line, right? This one over here, I think it was, is a line. This one's not a line. This one is separate dots. So this data is what we call discrete data. In other words, there is set points that it can be. It cannot be all these points in between, right? On the line, we had an infinite number of points that it could be on that line, right? This one's got a set number of points. It's discrete data. You can only have x values of 0, 1, 2, 3, or 4. I can't have x values like 0.5 or 0.75 or 0.3895265, right? I can't do that. So which best represents the domain in this case? So in this case here, I want to find the domain. So my domain, once again, is my x values. Whenever you see the word domain, I want you to think x values. Whenever you see the word range, I want you to think y values, okay? So my domain, if I have discrete dots, that tells me automatically that I'm not going to have an inequality. If you're thinking of an inequality at this point, that is way off, right? No, 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 no. This is all bad, bad, bad. Don't do it, okay? Because this right here, whenever you have discrete values, that's when you need to make a list. Discrete values give us a list, right? So, or discrete data gives us a list where we look for domain and range. So I'm going to go ahead and start by making my lists. Let's start by making my braces rather. So my list is getting ready. I actually probably shouldn't do the last one because you don't know how big your list is going to be, right? But in this case here, I'm going to start because they're looking for x values. I'm going to make my x values from least to greatest. So I'm looking for my least x value. My least x value looks like it's this 0 right here, right? This point here is at 0 for x. So I'm going to choose 0. My next x value is at 1. My next x value is at 2. My next x value is at 3. And my last x value is at x equals 4. So this, once again, is my domain. Just for kicks and grins, guess what? Let's do range. I just like doing range. Range is fun too. So my range, if I really wanted to do my range, right? It's not asking for it in this problem, but if I wanted to do it, I just want you to recognize my range would be 0, because you always start with the least one here, 0. Then it looks like it'd be like 50, right? then it'd be 100, right? Then it'd be 150, right? And then finally it'd be 200, right? That's just a freebie, not actually necessary in this problem, but I just wanted you to know how to do it in case they ask for it. So anyway, but this is our answer, the domain. Which one does that represent there? Well, it looks like B could be the right answer, right? Notice that A is almost the right answer for range. Notice they didn't put it in least to greatest. Always put your answers from least to greatest. Very important, all right? Otherwise, I'm only giving you half credit. I might not give any credit for this test, but I don't know. We'll see. So anyway, my answer then is this one, B. Don't get tricked and think it's C. Remember, you can't have x values that are anything from 0 to 4, because anything from 0 to 4 would include like a point here and here and here, and those points don't exist because it's discrete data. So once again, B is my final answer. Moving on. Ding! Expand this expression. Piece of cake. To expand this expression, we just use distribution. You've been doing this for a while. We're going to multiply that 4 into both all the terms inside the parentheses. So we get 4 times 6x is 24x, right? And then we get 4 times a negative 2, which is negative 8, right? That's my expanded expression. It's really that simple. Here, I'll give you another one. Freebie. Look at this. 3x minus 4. Everyone go ahead and do this real quick. 2 times 3x is 6x, right? 2 times negative 4 is negative 8. Cool, huh? Isn't that fun? All right, moving on. Here we go. So anyway, that was just a freebie. Oh, the time is up. Let's see. Oh, okay. I'm going to do one last problem before we go. Here we go. I didn't get to as many as I'd hoped, but we'll go with this one. Alexa, stop the timer. Last one, and then we'll move on. So simplify. Answer uses only positive exponents. Don't forget, this is the story that I tell my students. I talk about this guy. This poor guy. He lost his girlfriend. He's living on this side of the railroad tracks, right? He's like, I'm going to draw the actual fraction bar. I use the fraction bar. My analogy is it's the railroad tracks, right? The problem with him living on this side of the railroad tracks is it's just really sad for him. He sees his girlfriend all day long. It's a really sad scenario. He sees her at HEB, he sees her at Walmart, he sees her at the park, he sees her when he's walking his dog, he sees her when he's taking out the trash. So he sees her all the time because they live basically in the same neighborhood, right? So it's just not a good situation for him. The best thing he can do at this point is, or one of the best things he could do, is to make a positive life change. The way he makes that positive life change is he decides to move to the other side of the railroad tracks. When he moves to the other side of the railroad tracks, that's a positive life change. So his exponent becomes positive. All right? That's just how I tell my kids to remember it. The easy other way to remember it is if you have a to the negative n power, right? That is equal to 1 over a to the n. All right, you could just remember it like that, dude. That's the negative exponent rule. But basically, I just wanted to tell you that story. That's the story that I always like to tell because it kind of helps you remember that if you have a negative exponent, you can move it to the other side of the fraction bar, and it will change its sign to the opposite. If I wanted once again to move it to the other side, right? If I move it back up here, then it's going to become negative 7 again, right? And I don't need this 1 underneath it, but I'm just showing you I flipped it to the other side, right? So you could do that so many times. Anyway, I just want to wish you the very best. A couple of things you need to finish on your paper. I want you to write "I'm awesome" in the bottom left-hand corner of your paper. Write "I'm awesome" in the bottom left-hand corner of your paper. All right? So once again, in the top right-hand corner, you should have your name underneath your name, your first and last name. You should have "Math is my life." You should have your period number, and you should also have the date. In the bottom right-hand corner, you should have had a caterpillar. You should have "I'm awesome" in the bottom left-hand corner of your paper. And then in the upper left-hand corner of your paper, the very upper left, I want you to draw a shooting star. A shooting star, because that's what you are, because you're amazing for having done this video. I wish you the very best on your tests. Thank you for studying with me, and don't forget the other parts of the study sheet are out there. This is just like the least that you should do, right? Get that credit for it, but do the other parts of the study sheet so you're getting all the problems that could possibly be on it. We obviously have a limited amount of time to work with here, but I want you to get the full benefit of it. So do the other part of the study sheet. Once again, I hope you're having a great day, and I'll talk to you soon. Good luck.